All right, in Chapter 6, we're going to be talking about polynomials. The first goal that we have is to be able to use the properties of exponents, multiplying, divide, and simplifying monomials using the properties. And this is actually a review from Algebra 1, so it should be familiar to you. So all of the properties are found on page 333 in your textbook. You can look back over them, but I'm going to go ahead and go through each one of them to refresh your memory. Before we do that, go ahead and copy down this vocabulary. Things that you need to know. A monomial is, mono means one, it's a one-term expression. So it's a number, it's a variable, or a product of numbers and variables. So numbers and variables multiplied together. There should be no addition and no subtraction in it to be a monomial. And so you could have like x is a monomial, 3 is a monomial, 3x squared is a monomial. So anything that has one term in it with numbers and variables is a monomial. Now powers is an expression which has an exponent. So like 2 to the 5th power, we know that that really means 2 times 2 times itself 5 times. Z to the 8th power means z times itself 8 times. It has some parts. Of course, we know the exponent here was 5 and the exponent here was 8. The number underneath the exponent is called the base. So in z to the 8th, z is the base. Now, in all of these properties, we're talking about things that have the same base. So you can only do these properties that have work with the same base. Like if you have a base of x or a base of y, y's go with y's, a's go with a's, b's go with b's. All right. So the first property is product of powers. That's when you're multiplying two things that have the same base. You're going to add the exponents. Now here's the reason why. Down here, you're going to go ahead and take the coefficients and multiply them as normal. So negative 3 times negative 5 is positive 15. So that's just normal multiplication. Now, b to the 5th power means b times itself 5 times. b to the 6th power means b times itself 6 times. So when we multiply that together, we've got really 11 b's altogether. So that should give me 15b to the 11th power. Now the shortcut to that is just simply doing 5 plus 6 gives you 11 b's. Over here we've got coefficients. 6 times 3 is going to give us 18. We have 3 x's and 5 y's in the first monomial. In the second monomial we've got 3 x's, so when we multiply those together we can only do x's with x's. So we've got 3 here, that gives us 6 x's. 3 plus 3. And then we only have, hold on. So we only had one base of y, so we go ahead and just bring that down. All right, so we look for the coefficients. We only have one coefficient, so we bring down the 3. Then let's go in alphabetical order. So start with m's. M's to the 3rd power, there are no other m's, so we bring down m to the 3rd power. N to the 4th, n to the 5th, we do 4 plus 5 is n to the 9th. P to the 2nd, p to the 5th, 2 plus 5 is p to the 7th. Over here we have 3 times 4, that's 12. X to the 4th, x to the 1st power. Anytime there's nothing written there, we know that's going to be a power of 1. So x to the 4th and x to the 1 is x to the 5th power. Y to the 5th, y to the 2nd is y to the 7th power. And then we only have one base of z, so we just bring that z squared down. The next property is very much like the first one, except for now we're dividing. So when we were multiplying powers, we added the exponents. Here when we're dividing, we're going to subtract the exponents, the top minus the bottom. The coefficients we're going to divide just like normal, but notice we have in the top we have 4 n's multiplied together. In the denominator we have 3 n's multiplied together. So you can think of this as being n divided by n. Anything divided by itself is the number 1. So those cancel out. Those cancel out as the number 1, and those cancel out as the number 1. So we have 2 divided by negative 2. That's going to give us negative 1. Times 1 times 1 times 1 is still negative 1. And then we have this 1n left over in the numerator. So our answer is negative 1n, or we could write that as negative n. So the shortcut to that would be 4 minus 3 is n to the first power. Over here, we're going to do 4 divided by 2 is 2. X to the fourth divided by x to the 1. 4 minus 1 is x to the third power. And z to the second divided by z to the 1 is going to be z to the 1. Negative exponents. What a negative exponent means is they're wanting you to do the reciprocal. So if you have a base that has a negative exponent, you can simplify that by putting that power in the base, and the exponent becomes positive. Now, if the negative exponent is in the denominator of a fraction, it's going to jump up into the numerator. Okay, so the way that I do this is I go ahead and I simplify the multiplication or the division, and then we put any negative exponents where they need to go. So here we have 4 times negative 1. That's going to give us negative 4. Now we have x to the negative 2 and x to the 5. So negative 2 plus 5 is going to give us x to the third power. So that's going to stay where it is. Then we bring down the y to the negative fourth power, since that's the only base of y. And notice we have this negative power. So that means that this y is going to go to the denominator, and the power becomes positive. Let's do number 8. 4 divided by 2 is 2. A to the first power divided by a to the negative 4, we're going to do 1 minus negative 4. That's going to give us a to the fifth power. Then we have b to the negative 3 and b to the 4. So we do negative 3 minus 4 is b to the negative 7. And since we have a negative power, that needs to go to the denominator. So the 2a to the fifth power stays in the numerator, and the b to the 7 goes to the denominator, and the exponent becomes positive. A power of a power means that you have a power inside parentheses raised to another power. When we do this, we're going to multiply. So k to the third, we're going to multiply those powers. 3 times 3 is 9. P to the second to the negative 1 is going to be p to the negative 2 power, but notice it's a negative, so we're going to have to take care of that negative by doing the reciprocal. So that's going to be 1 over p squared. A product of powers is where you have things multiplied inside the parentheses and a power on the outside. This is kind of like the distributive property. That power is going to go on each thing inside so that you get x to the a and y to the a. So here we have a to the third to the fourth power. It's a power of a power, so we multiply those. So we're going to have a to the 12. 3 times 4 is 12. Then we have b to the negative 2 to the fourth power, so that's going to be b to the negative 8. Negative 2 times 4. And then go ahead and bring down that a to the fourth. Now notice we have more than one a, so we need to take care of that. So 12 plus 4 is going to be a to the 16th. Bring down b to the negative 8. And now we have a negative exponent, so that needs to go to the denominator. So we've got a to the 16th over b to the 8th. Now number 12 looks really complicated. Notice that we've got this fraction bar, so we're going to simplify the numerator as much as we can, simplify the denominator as much as we can, then do our division. So first we do the coefficients. There's just a 2, so we bring it down. We do u's with u's. U to the first power, u to the second power. 1 plus -2 is u to the -1. We have v to the -4, v to the -4. That's going to give us v to the -8. And then down here we have a power to a power. So -2 times -1 is going to give us u to the 2. And v to the -4 times -1 is going to give us v to the 4th. Now we're ready to do our division. We have 2 divided by, our coefficient here is 1, so that's still going to be 2. We have -1. Since we're dividing, we're going to subtract the exponents. -1 minus 2 is going to give us u to the -3. -8 minus 4 is v to the -12. And then we take care of our negative exponents. They go to the denominator. So the 2 stays where it is, and those negative exponents go to the denominator and become positive, of course. Power of a quotient, same thing. The exponent on the outside of the parentheses goes onto both things, the numerator and the denominator, everything inside. So since we have 4 over k to the -3rd power, we're going to get 4 to the -3rd power and k to the -3rd power. Now notice that both of these are negative exponents. So this 4 is going to go to the denominator and the k is going to go to the numerator. So we get k to the 3rd power and 4 to the 3rd power. And we can figure out what 4 to the 3rd power is. That's 4 times 4 times 4, which happens to be 64. So our final answer is k to the 3rd power over 64. Our final property is the 0 power. Anything to the 0 power is 1. It doesn't matter what it is. It could be an elephant to the 0 power. It's going to be 1. So notice this whole thing. This looks really complicated, but we can save ourselves a lot of trouble by noticing that the exponent on the outside of the parentheses is to the 0 power. So all of this to the 0 power, our answer is simply 1, because that's what the 0 power means. Now let's go ahead and work one that is a little more realistic. We have a 0 power here, so anything to the 0 power is really 1. So that we have a 2, this becomes a 1, and we still have our n to the 2nd power and our denominator here. Now our denominator is, notice there's a -1 out to the front, that's our coefficient, and then we have n to the -3, and it's all raised to the 4th power. So remember to put those parentheses around that -1 to the 4th power, and then n to the -3 to the 4, we multiply those exponents, so we get n to the -12. We're going to go ahead and simplify this multiplication in the numerator and denominator. We've got 2 times 1 is 2, n to the -2. And then -1 to the 4th power is -1 times itself 4 times. That's +1, n to the 12th. And now we can go ahead and do our division. So 2 divided by 1 is 2. N to the -2 divided by n to the -12. We're going to do -2 minus -12. That gives us n to the 10th power, and we're done. So the way that we know that we are done simplifying a monomial is that there are no more powers of powers. Each base only appears once, so there's only one x term, there's only one z, there's only one whatever. All the fractions are in simplest form, so you've got to reduce fractions, and there are no negative exponents. So if you have a negative exponent, it's got to be moved. So that covers our first goal, which was learning to use, or reminding ourselves how to use the properties of exponents to simplify monomials.